So homework number 10 onto amortized loan payments. Okay, and so for this one, we will need to utilize this formula to, come on, show it. Show it. There we go. So we'll need to utilize this formula in order to solve the following question. So let's go ahead and do it. So consider a student loan of $15,000 at a fixed APR of 12% for 30 years. Wow, why would you go over 30 years at only $15,000? Ridiculous. Okay, so calculate the monthly payment. So let's go ahead and utilize this formula to solve for the monthly payment. So we have PMT, which, as you might anticipate, does stand for payment. And the payment is going to be equal to P, the principal, multiplied by APR over N. And then that whole chunk is going to be divided by the quantity 1 minus, left parenthesis, 1 plus APR over N. And that whole chunk is raised to the negative N times Y. And then close. Okay, so 15,000, that's going to be the principal. The APR is 12% or 0.12, and we're doing this for 30 years. So let's go ahead and fill in our equation. So this is going to look like 15,000 times the fixed interest rate of 12%, well, that's 0.12, divided by N. Consider a student loan, 15,000 fixed APR, 12% for 30 years. Calculate the monthly payment. Okay, so N. So there is a difference between the N that's shown within this equation and the one that was listed in the previous equation. So the N here is the number of payments, not to be confused with the number of times interest is applied. So, and I do believe it's standard to have interest applied daily, if I'm not mistaken, or at least my interest for my student loans accumulates daily, which is pretty close to continuously. In fact, if you use those that same equation from before, you can see that daily and continuously virtually the same when you're talking within context of interest accumulating and how much has accumulated. Just some food for thought. Okay, so we're going to take APR and divide it by N, which is the number of payments you make in a year. Well, they're monthly payments, so you're going to be making 12 a year. Hopefully, if all things go as planned. And we're going to divide this by the quantity 1 minus the quantity 1 plus APR, 0.12 in this case, divided by N, still 12, and that quantity is being raised to the negative N, which is 12, times Y, which is the number of years we're doing this, which is 30. So, in calculator notation, so with my pretty print calculator, I can shove this in exactly how I see it. However, if you do not have that nice pretty print feature on your calculator, we're going to have to type this in one step, or else we're going to accumulate rounding errors. So in standard calculator notation, this is going to look like 15,000 times, do I want to do the print? Yeah, let's go ahead and we're going to do the parenthesis just so you can see how this kind of unravels. So left parenthesis 0.12 divided by 12. So that takes care of our numerator, and then we have to divide by our denominator. So I'm going to do divide by left parenthesis to start this bracket, 1 minus another left parenthesis 1 plus 0.12 divided by 12. So that takes care of this piece in parentheses. And now on to the exponent. So we want to take this chunk in parentheses and raise it to the negative 12 times 30, right parenthesis, to finish off our exponent, and then we'll add one more right parenthesis to finish off our denominator. So do be aware, in a calculator, this negative, you cannot just hit the minus sign for a negative. On a calculator, there is a negative button. The calculator reads the subtraction symbol as an operation. You don't want an operation, you simply want a negative, so you want to use the negative key or button. So let's go ahead and type this in, and I'll show off my excellent pretty print feature. So I'm going to start a fraction at 15,000 times 0.12 divided by 12 divided by my denominator of 1 minus left parenthesis 1 plus 0.12, and let's go ahead and insert a denominator of 12, and then I'm going to raise that whole chunk of stuff to the negative 12 times 30. Close off my denominator. Make sure I got this all in. Alright. Hit enter. And we get 154.29188. Blah 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 blah. Do not round until the final answer, then round to the nearest cent. So kind of common for money-based problems. 1 is not enough to round up my penny, so it sits at $154.29. So 154.29. Moment of truth. Yeah, feels good. Even as a teacher, that feels good. The total payment over the term of the loan is what? Okay, so first things first, before we proceed, typically if a student messes this problem up, where they mess up is right here on this exponentiation. So students have a tendency to put this exponent upon this whole piece, so 1 minus 1 plus, blah. So recognize, if you do not have this 1 plus APR over n in parentheses, you end up getting 1 minus 1, which is 0. So 0 plus 0.12 divided by 12. That gives you a very small decimal, and then you take that very small decimal and you raise it to a large number, making it even smaller. So keep in mind that this exponent is only being put upon the 1 plus APR over n. Exponent is only going on this 1 plus APR over n. So if you end up getting this problem wrong, inspect your denominator and be sure that this exponent is only put upon this base. The base meaning 1 plus APR over n. And then this 1 minus is sitting outside. So do not include this 1 minus inside of these parentheses, or else you get a very small number raised to a large exponent, and things go nasty in a hurry. So on to the next one, the total payment over the term of the loan. Well, I mean, recognize you're making this payment $154.29. You're doing that 12 times a year, and then you're doing that for 30 years. So we're going to take the monthly payment, multiply it by 12 to figure out how much you pay in a given year, and then multiply it by 30 to figure out how much you pay over the life of the loan. So that's $154 per month multiplied by 12 months to get how much you pay in a year, multiplied by 30 years to get the total over the term of the loan. 154.29 times 12 times 30. Well, that gives me 55 $58,545.08. So recognize you took out a loan for $15,000, and because you drug it out for 30 years and you only made the minimum payment, you end up paying over $50,000. Not good. So for all the students out there, whenever you take out an amortized loan, you always want the term of the loan to be the shortest as possible. The shortest such that you can still afford the monthly payments. And then at that, do not make only the monthly minimum. Put more than the monthly minimum on to save some money in the long run. So the total payment over the term of the loan is $55,545. Of the total payment over the term of the loan, blank percent is paid towards the principal and blank is paid towards the interest. Okay, so you pay a total of this $55,000, and $15,000 of that, exactly $15,000 of that went towards the principal, because that's what you borrowed. You borrowed $15,000 in principal and you paid back $55,000. So to answer the question, how much or what percent went towards the principal? So recognize the percent that went towards the principal. Well, that would be 15,000 over your 55,545.08. So recognize what you have here is you have the total on the bottom. This is the total that you paid, and what you have up top is the principal that you paid. So if you're looking for the percent of the principal with respect to the total, that would be this. Think of it like a test score. There was this total options, 55,000, and you got 15,000 correct. Quasi, along those lines. Percentage, I always try to encourage you to think about a test score, because that's kind of the most natural way to think about it as a student. So taking the 15,000, the amount you paid in principal, dividing it by the total, you get 0.27005. So as a percentage, this would be 27%. So if 27% of your money went towards the principal, the leftover would have to go to the interest. So that would be 100%, subtract off 27% to see that 73% of what you paid went towards the interest. So recognize there is a tremendous difference between the APR, the annualized percentage rate, and the actual interest rate that you pay. Absolutely astonishing. Absolutely astonishing and heartbreaking at the same time for a lot of reasons. So 30 years, 12% interest, a principal of 15,000, you end up paying over $55,000 back on only 15,000. This is this would be a pretty nice used car for 15 grand, or even a brand new lower end car, cheaper car. This 55, that's a very nice pickup. So think about what you're borrowing and what you're paying back, and then from that deduce the fact that you want to pay more than this monthly minimum to reduce this amount of interest. But nevertheless, let's go ahead and check our answers. Moment of truth. All right, that feels good. Okay, I'll let you try out the rest. I'll see you on the next one.